I'm going to describe the use of an interactive simulation that models the Rankine cycle for power generation. Now, the simulation is located at the link that's given here, and what we're plotting in the simulation is the pressure enthalpy diagram. The cycle goes in this direction where we take a liquid, vaporize it, superheat it, then we run it through a turbine where the green line represents a reversible turbine, and then the black one represents one with an efficiency, in this case, of 75%. The exit from the turbine is then condensed at constant pressure to a liquid, which is then pressurized back up to our original pressure that entered the boiler. And so we can control the inlet pressure and the outlet pressure. So that's inlet pressure to the turbine, outlet pressure to the turbine, P3 and P4, and we can control the efficiency. So let's look at this simulation. So in the simulation, the details describe how we generate the plot. The turbine is shown here, so as we change the efficiency, you can see we get more work out for the same inlet and outlet pressures. We can change these pressures, and that certainly affects the amount of work we get out. And then here is the schematic of what the Rankine cycle looks like. We put heat into the boiler to vaporize, and then the turbine is where we generate the work. We have to put a little work into the liquid pump, but that's a small number compared to this number typically. And we remove heat at the lower temperature, the lower pressure. So PV diagram, if we change the efficiency, then we're getting significantly less work out since it's a difference in enthalpy between 3 and 4. And if we lower the outlet pressure, you can see the cycle efficiency, which is how much work we get out of the turbine divided by how much work we put in the boiler. If I increase the pressure of the boiler, you can see the efficiency goes up some. We're getting a little more work out. Lower pressure, we get less work out. So this is a simplified version of what's used on large scale to generate power. There's additional things that can be done, but the basic concept here is we take steam at high pressure and we run it through a turbine to generate work, and then we condense it back to a liquid and go through the cycle again.